Okay guys, this one is theorem number 1 in grade 11 about circle geometry. What is this theorem? The line drawn from the center of a circle perpendicular to a chord bisects the chord. So guys, what do you mean by a chord? Chord is the line joining 2 points on a circle. For example, this point is A and this point is B. So if you draw a line joining 2 points on a circle, this line is known as chord. Okay, make sure that starting from a point on a circle, finishing at another point on a circle. If you join, you will get a chord. And in that way, the longest chord is diameter, isn't it? So the diameter is also starting from a point and finishing at a point. And then go to the theorem, the line drawn from the center. Where is center? Center is somewhere here. Let me use the letter O. Most commonly we use the letter O to represent center. And if you draw a line, that is also given, line from center to chord. Okay, if the line is making 90 degree, that is perpendicular. If you get 90 degree in between, let me write M here, the point of contact of a line with the chord. If it is making 90 degree, then you have to prove what AM is equal to BM. That's the question. You have to prove that the M is the midpoint or the line bisect. Bisect means cut into equal parts. All right, so how do we prove this theorem? This is a very important theorem, and this is the one that commonly they ask in the exam. Okay, its corollary, its converse also there. That is, the result is important, but that theorem normally it's not coming in the exam or test. Okay, this is very important. Perpendicular from center to chord. So wherever you apply this knowledge, you have to write. The reason is perpendicular. This is the reason, the one that is inside the bracket. Perpendicular from center to chord, you have to write it in the bracket whenever you apply this result. So how do you prove this one? That AM is equal to MB. For that, you have to construct two radii. See, OA like this. See this one, OA and OB. See, OB. Now you can see two right angle triangle, and you have to prove that those two right angle triangles are equal, congruent. Okay, if those two triangles are congruent, then corresponding sides are AM and MB, and automatically they are going to be equal. All right, so that's the one that you have to do it. So how do you write this theorem as theorem, the proof of this theorem? How do we write it? You have to first write the given items. What are the items given here? Given OM, of course circle with the center O is given, and OM is perpendicular to AB, isn't it? And you have to prove what? Prove AM is equal to BM, isn't it? For that you have to construct what? OA and OB, that is the radii. Okay, OB, bracket we can write radii. Radii is the plural of radius. Okay, now how do you prove that these two triangles are congruent? Congruent means they are same. The corresponding angles are same, corresponding sides are also same. Isn't it? Triangle means 3 sides and 3 angles. So all of them are same. Once you prove that they are congruent. So some conditions, you know that the rules are SSS, SAS, SAA and RHS. If it is a right, if you are proving two triangles are congruent and they are right angle triangle, then we are using RHS. So like here, they are right angle triangle. So you have to prove that they have 90 degree, their hypotenuse are same, and there is a the corresponding one pair of corresponding side also same, then we are done. So you know that OM is common in both, isn't it? So proof, you have to write proof OM is common, isn't it? So OM is part of both triangles, common. So one pair of side is there. Now what? The hypotenuse. What are the hypotenuse? OA and OB. Are they same? Yes, of course. Why? They are radii, isn't it? Radii. Radius, if you draw anywhere in the circle, they are same, isn't it? What do you mean by radius? From center to circle, isn't it? From center of a circle, join a line to the circumference of a circle is known as radius. 2 times radius is diameter. Okay, so OA is equal to OB. They are radii. Radii. So hypotenuse H also, the hypotenuse of both triangles are same because they are radii, right? Now 90 degree. It is given that 90 degree, isn't it? Let me call this one is M1, M2 or AMO, BMO. You can call by letters also. There's no problem. So let me write it M1 is equal to M2 is equal to 90 degree. So it's given, right? Given. So R also here. So by RHS we can say that those two triangles, that is, what are the triangles? Triangle OAM, that order is very important. OAM is congruent to triangle OBM, isn't it? Okay, so we proved that those two triangles are congruent, which means the corresponding sides are same. So from the name we can get the corresponding sides. What are they? See, AM and BM, they are same, isn't it? That's the one we need to prove here. Yes, AM is equal to BM. Therefore we can write AM is equal to BM. So we are done, which means M is the midpoint and the line bisecting, isn't it? So it's a very important theorem, perpendicular from center to chord. Perpendicular from center to chord. Okay. All right, now it's converse. Converse means opposite of the first theorem. What is that? The line drawn from center of a circle to the midpoint of a chord is perpendicular to the chord. Okay, so here the reason is line from center to midpoint of chord, isn't it? So here what is given? Midpoint is given. I have to prove that the line is perpendicular. So let me draw the chord. Chord AB. And M is the midpoint. It is given that M is the midpoint. And if you join from center, it's not center. Center is somewhere here. If you join a line to the center, if you join it, then that angle between that line and the chord is always 90 degree. So here the given part is, I will show you the proof, but it's not that much important. The first one is important, okay? But I will show you that given AM is equal to MB. That is, M is the midpoint of the chord, isn't it? So AM is equal to MB. And you have to prove what? Proof OM is perpendicular to AB, the opposite of the previous one. So here also the construction part is join OA and OB, like this, OA and OB. Clear? So you have to prove what? It's 90 degree. Okay, that M1 and M2 are 90 degree. Clear? All right. So here 90 degree is not given. You have to prove that perpendicular. So here what is given? M is the midpoint, isn't it? Okay. So how do you prove this? Proof. So here also construct what? OA and OB. They are the radii, isn't it? So how do you prove? I will write the proof here. OA is equal to OB. So because they are radii, right? Radii. So one pair of S is there. Then OM is common. So another pair of S. Then what is that? AM is equal to BM. That is also given. So next pair. So we are using S to show that these two triangles are congruent. So triangle OAM is congruent to triangle OBM. See, the previous question we used RHS because 90 degree was given. Here 90 degree is not given. Here what is given? M is the midpoint. So these two triangles are congruent because of SSS. Three pairs of corresponding sides are same. That is also one of the conditions to show that the triangles are congruent, which means their corresponding angles are same, corresponding sides are also same. So when it comes to M1 and M2, did you see that OAM and OBM, which means M1 and M2, they are same, isn't it? So we can write, therefore, M1 is equal to M2, corresponding angles are same. But what is M1 plus M2? M1 plus angle M2, I'm talking about the angle, M1 plus M2 is 180 degree, isn't it? Isn't it angles on a straight line? So 180 degree and they are same, isn't it? So M1 plus M2 is equal to 180 degree. What is the reason? Angles on a straight line. On a straight line. Okay, at the same time they are same, which means M1 must be equal to M2 is equal to what? 90 degree. Since they are same and their sum is 180 degree, means each of them must be 90 degree. Isn't it? Which means OM, the one that we are looking for, what is that? OM is perpendicular to AB. So these two theorems converge. The idea wise you have to use this, that is a line from center to midpoint of a chord in many questions. Okay, yes, I hope it is clear. These two theorems, especially first one is important, second one the idea is also important. We are going to use this idea, both of them, in different questions. Let's do one question. Look at this question, example number 1. OC is a radius, yes, or from center to circle. OC is a radius, I hope you understood, and cut the chord AB at M. Okay, that also we can see there. OC is 17 millimeter. OC, that's the length of the radius, is 17 millimeter. Okay, and AB is 30 millimeter. And OC is perpendicular to AB. Did you see the first theorem? OC. O is center and line from O is perpendicular to the chord, means bisect the chord, which means AM and MB, they are same. So AM is what? Because from A to B is 30. Isn't it? That is from here to here is 30, which means AM is what? It's going to be 15. And this also 15. Is it clear? Calculate the length of MC. You have to calculate this length. MC you have to calculate. OC is 17. So how do you calculate MC? If you know OM, you can calculate MC. Just subtract that OM from OC. Isn't it? That OM, somehow I need to get it. For that, I need to construct a radius OB. See, like this. And OB and OC, they are both of them radii, so the length is 17, isn't it? All right, so now we can calculate what is OM using Pythagoras, isn't it? So you have to first make sure, first to show that why that 15 millimeter you got it there, that is AM is equal to MB. That you have to mention here, that is very important. AM is equal to MB. What is the reason? Perpendicular from center to chord. Perpendicular from perpendicular from center to chord. That is the first theorem, isn't it? That is why the results are very important, which means MB is equal to what? 15 millimeter. Is it clear? Okay, so, and I constructed OB. Okay, so I got a right angle triangle, what? OMB. OMB. We can apply Pythagoras theorem there. That is OB square is equal to OM square plus MB square. So whenever you write a Pythagoras, always start with the right angle triangle. I mean the hypotenuse square is equal to sum of the squares of, that is 17 square is equal to OM square, that we are looking for OM, plus MB. MB is 15 square. That is OM square is equal to 17 square minus 15 square. Isn't it? What is 17 square minus 15 square? 17 square is 289 minus 15 is 225, which is going to be 64. That is OM square is equal to 64. Therefore, OM is equal to square root of 64, which is going to be 8. So we got the length, this one is 8. So what is MC? We can calculate now easily, because OC is same as OM. You can look at the diagram, OM plus MC, isn't it? MC. Where OC is 17 and OM we got 8 plus MC. Is it clear? Therefore, we can calculate MC is equal to 8 send other side, 17 minus 8. That is MC is equal to 17 minus 8 is what, guys? Is 9 millimeter. So we got it. So this kind of question you can expect from this area. Okay. All right, guys. And I'm stopping here, and in my next video you can see another theorem, that is angle at the center 2 times angle at the circle. I will prove that one, and if possible I will do one example in that video. All right, bye.